All right, guys, in our last video, we talked a little bit about how about extinction and how biodiversity is important to us, and a little bit about the threats to it, and really some things about characteristics about the species themselves that makes them susceptible to extinction and to dying off. What we're going to look at in this video are the human effects. In other words, what effect do we have? How are we changing things that makes it harder to sustain the biodiversity of species? So let's jump right in. The idea here is we're talking about natural capital degradation. Now, we talked about this in one of the other videos, but remember, natural capital is just all of the natural resources that we have. So, the plants, the animals, the ecosystems, the water, all of those things, that's the natural capital that we're talking about. Degradation obviously meaning that it's getting used up, that it's being degraded in some way. So there's some underlying root causes here that are going to lead to this. The first of these obviously is population growth. We talked about that in the last unit, and we'll talk about it again here in this video really briefly. But just, the idea that the more people, the more things that are going to get consumed. That goes right along with this, that resource use rises as population growth happens. The third thing here is that, to be honest, we sort of don't value our natural capital very much. We are, particularly in the West, and particularly in the United States, we value actual capital or monetary capital, really. We don't really value natural capital that much. We don't think of our resources except really in the ways that we can exploit them, and that obviously is going to lead to some issues. And then the last thing, of course, that one of the underlying root causes is poverty. And you might think that one sounds kind of odd, like why would poverty sort of jump in there? And I mean, just think about the idea that, like, if you're poor or if you're in a situation of poverty, you're not really concerned with saving the environment. You're not really concerned with, well, I don't want to, chop down this wood for fire to heat my home. That tree is protected, or I don't want to, cause the soil to erode, so we need this tree here. And if you remember back at the beginning of the year, we watched the video on Haiti and how they didn't have any trees left. That poverty sort of comes out as a stark example of how poverty really matters environmentally, because you're concerned with survival first, and the environmental issues got to come after that for most people. And so that's one of the reasons why we see a lot of environmental studies in the United States, even though we sort of make fun of ourselves and say that we don't care about these things, because since we are wealthier and better off overall, higher standard of living, that tends to mean that you then have the luxury to worry about those things that people in developing countries or that are in dire poverty obviously don't have that luxury, really. So let's talk a little bit about some of the direct causes here, and you'll see some overlap here between the underlying causes and the direct causes, but that's okay. We mean these are the things that are actually going to right then degrade the things. The underlying causes, these are what lead into the direct causes for the most part. You want to remember this acronym, okay? The acronym is HIPCO, 2 Ps, and this will lead you into the 6 ways that we're going to talk about how natural capital gets degraded. The first one we mentioned a little bit in the last slide, and that is habitat destruction, degradation, fragmentation. So it's not always the destruction of the habitat. We always get the idea of, like, this means like, oh, a big swath of the rainforest is being clear cut. And that does happen, but there are just things that will degrade it. There could be pollution that's going to come in, and we'll see that in a second. We could split habitat in 2 by, say, building a road through it or a subdivision or something like that might break up a forest, and now those animals don't have all of that area to roam, and they can't really cross that area, so their habitat gets destroyed, basically, or it gets fragmented, but for their purposes, it's essentially almost destroyed. The second one is invasive species. We mentioned those back when we did a little bit on biodiversity last semester. We'll talk a little bit more about that, and we talked a lot about that. We're going to do some case studies in class to specifically examine some of those. Population growth, increasing use of resources. You'll notice that's sort of a continuing theme. That's where we started off this part of the year, and that's where we're going to continue to sort of hammer. Not because population in and of itself is bad, right? Because obviously, if we've got high economy and we're developing new ways and stuff, that's okay. But as the population grows, so does the consumption of resources. And so that obviously is going to lead to natural capital being eaten up. The second P here in HIPCO is pollution. We are going to talk really extensively about pollution later in the semester. So we'll just sort of briefly go over it. But I mean, it's not that hard to imagine how pollution obviously is going to hurt our natural capital. Climate change, another thing that we'll talk a lot more later in the semester, but we'll briefly mention how that can change things. And then overexploitation, and what we mean by that, we'll talk about at the end of the video. But it just means we exploit our resources. We tend to think that exploit is a bad thing, but exploit means we're using our resources, and that obviously is okay. Overexploitation means we're using them so much that we're starting to deplete them, and then they're not going to be there. They're not really renewable anymore. We're using them in unsustainable ways, essentially. So let's briefly go over each of these points just to give you sort of a broad overview. Some of them we've talked more about, some we'll talk more in depth about later. Habitat fragmentation. So that just means that the habitat is broken up in some way. So like in this picture, you see there's sort of a forest area here where you see some of it's been plowed for fields. There's a couple of roads moving through it. And so plants and animals aren't able to cross those barriers. I mean, we live in, roadkill capital of the world, it seems like, and animals can't make it across those boundaries. That essentially becomes now two separate habitats. And if there's not enough food in one of those areas, then obviously those animals are going to die off. So that's a pretty big deal. There are ways to mitigate this. In some places they build animal bridges, wildlife bridges. And sometimes they're over the road and sometimes they're under so that the animals can go through. Now, of course, the problem is you have to have some way to get the animals to actually go over the bridge instead of just trying to cross the road, because it's not really the most direct route. In Wekiva in Florida, in Wekiva State Park, they actually have a bridge like this for the bears, but they have a giant fence for miles and miles and miles that sort of funnels them to go in that place so that they only cross there, so that they're not getting hit by cars, which obviously is bad for the bears and bad for the cars also. So that's one of the ways you can mitigate against this. And this is one of these things of we can think sometimes environmentally about things and we want to protect the environment, but we also obviously have economic growth and expansion that people are doing, and we can find some ways to mitigate these things, and we should be looking for those ways. That's one of the things that I think as students here at STEM in particular, we need to start thinking about ways that we can mitigate some of those things. Second one is invasive species. Now, we talked about these earlier in the year. One of the things is that we tend to think of invasive species like a lot of times as animals, but a lot of times they're actually plants. Kudzu, obviously a great example. Water hyacinth is an awesome example. It really starts to clog up waterways. It clogs them up and essentially sucks out the oxygen and starts to kill the fish off. It clogs them up. Boats can't get through stuff. It gets caught in the motors and stuff like that. Japanese beetles here, another great example. Killer bees, Africanized bees. Killer bees is sort of a little bit of a misnomer, but Africanized honeybees, which are a lot more aggressive. Like normal honeybees don't really attack very often, and they don't swarm when they do, but Africanized bees do. And all of these species were actually deliberately introduced into the country to solve some sort of problem. This is one of these ideas that we talked about at the beginning of the year, sort of that law of unintended consequences, that when you introduce something in to an environment that it wasn't originally there, yes, it may take care of your problem, but it may also start to get out of control. I think kudzu in the South obviously is a great example for us about how it's overrun areas, and water hyacinths are as well, where they're really a pest species now, and we really have to find some way to try to get rid of them. Same deal for Japanese beetles as well. And then, of course, there are accidentally introduced species, and really I've got a little bit of a qualm about some of this because the pythons here, I love this picture. This is a Burmese python. It's wrapped around an alligator in the alligator's mouth as well. And right now, as of this moment in Florida, again, you can make your little marks there. Right now, they're having a Burmese python hunt. Essentially, the state is sponsoring one to see who can kill the most pythons, who can kill the biggest python, because what happened is people would essentially smuggle them in to use as pets because, like, hey, cool, pythons are awesome. And then they didn't really realize that Burmese pythons get to be huge, okay? We're not talking like 4-foot-long snakes. They can easily be up to 4 or 5 meters long. And so they're kind of unsupportable in a house. And so what would people do? Oh, well, we're in Florida. I mean, snakes like the swamp, so I'm going to go dump them out in the Everglades. And they didn't really have many natural predators, and they really started to destroy things and really became sort of a plague on South Florida. And so they had to go in. And now, as of right now, they're hunting those down for prizes. Mosquitoes are another great example. This is how West Nile gets transmitted, and they weren't purposely introduced in the country. And of course, Argentinian fire ants, another awesome example. They're just now, in fact, as I was doing some research on this, they just last year started to reach Monroe County. And fire ants are a big plague. They're really hard to get rid of, and the things that you use to kill them off actually kill off the native ant species, and the native ant species have a vital role in the ecosystem. So if you're trying to kill off the fire ants and you kill off the native species, then that's bad news. Plus, what generally happens then is the fire ants move back in because there's no native species around. And so, again, big problem there. And this wasn't a case of law of unintended consequences. They came up. They might get stuck on car tires or maybe in some agricultural products, and they establish a new home. And they flourish because they don't have any natural predators. That's the case with just about every invasive species. If there's no natural predators, then it's really tough to remove those invasive species. Population growth, we've been harping on this for a couple of weeks. I'm not going to hammer this much more, but just remember the essential idea here that we're looking for, this is the first P in HIPCO, is that the more people, the more land use, the more resource use, more habitat destruction, the more pollution, all of those things go along with higher population growth. The second P is pollution, and we're not going to talk a lot about pollution right now because we're going to do whole units on it later. But I want to put this idea out there and sort of get this percolating around in your head, and that's the idea of bioaccumulation. If you remember back at the early part of the year, if you look at this diagram should look kind of familiar. It looks almost like an inverted trophic level. Because remember, trophic levels were big at the bottom and really small at the top because the energy basically went down as you went up the chain. Okay, well, here's the bad news. Poisons actually work the opposite way. That you've got a really low amount, but as it goes up the trophic level, as it goes up the food chain or the food web, it gets more and more concentrated so that it then starts to kill off fish or the birds that eat the fish, or it's dangerous for people to eat. They can't eat the fish anymore because even though there's not a lot of that pollutant in the environment, it gets concentrated as the fish eat the zooplankton and the smaller fish, and it gets concentrated to the point that if you eat a lot of a certain type of fish or something in an area where there might be mercury around, it accumulates and it gets to be dangerous. And so I just want to get this idea out in your head. We're going to talk a lot about DDT later in the year because it's one of these things that was a massive success story and also like one of our worst environmental disasters all simultaneously at the same time. But it's a great example of this idea of bioaccumulation and the biomagnification, essentially, meaning that you get more and more that what was initially a really small amount is going to be a big amount. Now, why does that work? Well, remember your trophic levels again. The top level predators here have to eat a lot of each level below them because they're not getting as much energy. Okay, energy gets lost in each trophic level, and so that's going to get concentrated. The bird has to eat a lot of fish, and if the fish already have it concentrated in them, it's going to be even more concentrated in the birds, and so that's bioaccumulation. Climate change, I almost hated to put this picture because I didn't want it to be such a cliche, but I think it's definitely one of the things that we sort of immediately jump to when we think about climate change is that the ecosystems in the Arctic are going to change pretty rapidly. I think we can see increasing evidence all around the world that it's definitely not just an Arctic issue, so we'll talk more about this later. But definitely as climates change, it changes habitats. You know, each biome, has a certain set of organisms, but it also has a certain temperature range, right, and precipitation range. And as the temperature changes, that affects the organisms that live there. And then as the temperature changes, it also changes weather patterns and climate. And so all of those things change. And so amounts of precipitation get altered. And so what was once a savanna might all of a sudden be a desert because it's not getting the same amount of rainfall. And so climate change is pretty dramatic, and it's going to have some pretty dramatic effects. And we'll talk a lot more about this. This map is just, this is a little diagram of projected changes by the middle of the century of the Arctic. And so if you see the red here, these are basically the ice-covered areas that are going to be gone. And we're going to have this smaller cap. And this was actually from a couple of years ago, so it's probably projected to be even smaller. It's smaller every year right now. So the last part of our HIPCO is overexploitation. And really there's a couple of parts of this, but one of the biggest is the idea behind poaching. There are a lot of animals out there that are rare, that are threatened and endangered, as we talked about in the last unit, that are worth enormous sums of money, sometimes for what would seem to our culture to be ridiculous things. A great example are rhinos. In a lot of cultures, they believe that ground up rhino horn adds to fertility, sort of like a, an organic Viagra, I suppose. And so what that means is that there's poachers that are going to go out and kill rhinos essentially for their horn because that's really valuable. Highland mountain gorillas go for around $150,000. Now they're endangered right now. There are not a whole lot of them out there. But if it's, think about it, if it's tens of thousands of dollars, people are going to go after that. Again, in a lot of cases, it's a poverty thing. If you're worried about money and survival, you're not going to worry that this species is endangered. You're thinking, I'm endangered. And so that happens a lot. Happens with tigers and tiger pelts. Elephants are other great examples. And all of these things, now there are treaties that we'll talk about and laws against this. That's what poaching means, of course, is that they're going against the law to go out and hunt and kill these things for various reasons. I mean, a lot of them are very tragic. I think rhinos are particularly tragic because a lot of times all they do is they kill them and take their horns, and then they leave the carcasses there. They don't even use the rest of them, which I think, at least in my mind, is particularly appalling. It's appalling overall anyway, but that is particularly so. So that wraps up our video on human effects. Anytime you're thinking about the human effects, just remember to jump back to your acronym there that we're looking at HIPCO. Okay, and as long as you get what those things are in your head, I think that you'll have a pretty good chance of knowing what the human effects then are on species biodiversity. All right, thanks, guys.